Alright, so in this video we're going to be discussing some linear functions. As you well know, the idea with a linear function, I'll do one of these first, and we'll kind of go somewhere else and try something different. Let's see, let's go down. There we go. Okay. So then you're like, well, alright, I can do this. So the slope, of course, is y1 minus y2 over x1 minus, x2, which is 20, negative 4, which is negative 5 for a slope. Of course, y equals mx plus b, and you get so y equals, of course, negative 5x plus 20. Piece of cake. Something to keep in mind here. When we see linear functions, you're going to be seeing some in tabular format like this. Okay, so the question is this linear or not? So down here it's pretty obvious we're adding 3. When we go up 3, we're going over 1. Up 3 over 1. That's great. But uh-oh, here we went up. Uh-oh, that means I can't add. Let's try it again, you goomba. It should be 68. Damn it. Darn it. Try it again. By George, I bet it works this time. These aren't affected. Here we went up 18 when we went over 6. Well, 18 divided by 6 is, look at that, 3 to 1. Here it's 21. We went over 7. 21 over 7 is also 3 over 1. 6 over 2 is also 3 over 1. And 12 and 4. 12 over 4 is also 3 over 1. And because it's always that same relationship, that is, I went over 3, I went up 3, I went over 1, 3 to 1, it's a linear relationship. For instance, had this been 51 here, well, that would have been 22. Uh-oh, 22 over 7 does not equal, for instance, 12 over 4, or one of the other ones. It does not equal, not linear. Right? Piece of cake, not too hard to do. Now remember, of course, you need 2 points to find the equation of a line. Why is that? Well, Mr. Groom, the geometry teacher told us you need 2 points to define a line. Yes, that person did. But why? Well, here's why, friends. Because when you write y equals mx plus b, there are 1, 2 unknowns here. For 2 unknowns, you better have 2 equations. You're like, what are you talking about? Oh, well, I'm fixing to tell you. So this is like 2 and, I don't know, 6. Sure. And this is like 0 and 9 or something. Okay. So what I can do is go 9 equals 0 times m plus b. Actually, I don't want to make that 0. Let's make it 1. Negative 1. Yeah, brah. And then, yeah. Mr. Grimm, this looks exactly like, well, could I do something with elimination? You're right. You're right. It does look like elimination. Watch me do this. Boop. Watch me subtract. Hey, look, the b's cancel out. How cool is that? And so I was able to solve for one of my unknowns, of course, plug it back in, and you will find that the other unknown is also, well, knowable. So b plus 1 is equal to 9. That means b is equal to 8. Ta-da! And again, the reason we need two equations or 2 points is because we need 2 equations to solve for those 2 values. Well, now wait a minute, just to cotton pick in a minute. Are you saying that on this one, this is a quadratic, of course, that we would need 3 points for a quadratic? Yes, that's what I'm saying. That is exactly what I am saying, friend. So suppose I did this. 1, 2, 0, I don't know, 9. Voila. I just made up some points. Listen, friends, they are nowhere near. Oops, what are you doing? That should be -1, my bad. They are nowhere near on a straight line. By George, they look like they ought to fit a quadratic. Weird. And so what you can do is actually plug these in. So -1 squared is 1. You get this equation right here. Voila. Now, of course, if these weren't zeros, we'd have to do a little bit more work. But that just says, look, C is 9. So now I end up with this equation here. And this equation down here. And so in other words, A minus B is equal to -7. 4A plus 2B -11 times the top row by 4. Subtract, the A's go away, you get -2B minus this be 17 looks like. Plug it back in, well that's 8.5, right? So then A plus, it's gonna be plus 8.5, right? And you minus it over there, you're going to get A is equal to -15.5. Or if you prefer, -31/2. So my equation would be Y equal, remember this is the whole point of doing this garbage. Now, are we going to do a lot of this? No. No, we're not. But again, it's just something that, in past, you may have had to fit an equation. You're like, oh, that's nice, or whatever. Or, oh, I just typed it into my calculator and I just hit regression. Okay, we were in class. We tried to make a graph fit. Blah blah blah. And all we did was we just plugged it in, and the calculator just spit out an equation. Isn't that neato? I guess I guess it's Q. I'm gonna put in my points if that's all right with you. Oops. Voila. And then let's type in my equation, and then we'll go back and take a look at it in a second here. So we got what? 31/2. So -31 divided by 2 x squared minus 17/2, I think. Is that what I said? That is not what I said. Pay attention to what you said, Jay. Apparently, that is not what I said, not even a little bit. So let's go check it out. -37/2, 31/2, 15/2. Alright, did I not type it in correctly? I did type it in where I thought. Well, we'll pause one moment for station identification. Well, let's see if I can figure out where I screwed. I found it, freaking hippie. It's negative, so this should have been negative. Shut up, so this should have been 6b when you minus a minus. So this should have been 17/6, which is positive. Darn it. And so that's 42. Minus 17 be negative 59/6, I believe. Let's try that. Okay, well, I changed that, there, but it was a positive over here, so it should have been a negative over here as well. So I should have added it. So let's try that again. That's why you should use a calculator, friends. Negative 25/6. I bet it works this time. What do you think? I bet it does. My goodness, it does. What do you know about that? Okay. Again, the whole point of that exercise was not to, make me look like a goomball. It was actually to practice solving the systems of equations. Again, we're going to continue to do that on as time goes on. But it's also to take a look at, when I have a quadratic equation, I need 3 points to find an equation that goes through the thing. All right, back to this. Suppose I have a line. It's y equals 2x minus 2/5 x minus 1. And I'd like it to go through the point 5, 9. Sure. Except I would like it to be perpendicular to this line. Well, you recall that perpendicular lines have negative reciprocal slopes. So flip it and change the sign, yes? Es muy bueno. Now simply plug in your points. Whee! And you go y, which is 9, equals negative 5/2 times 5er plus b. 2.5 times 5 is 12.5. That's a negative, obviously. Plus it over there, you're going to get 21.5. Oops. And this is your b. So y equal negative 5/2 x plus 21.5. Okay, nice. Just a quick little reminder. Some of you have forgotten, undoubtedly. Some of you are probably never very good at it. Be aware that some books, not this one in particular, but some books like to use what's called standard form, that is ax plus by plus c equals 0, or ax plus by equals c. Either case, it's fine. I prefer this method. Most books do, but once in a while you'll see it this way too. Just be aware that if you do see it that way, and you're like, geez, I don't know if I'm right, you could obviously graph it, but you look kind of like a dink doing that. So here's the thing. A must be positive. Okay? I should say technically it should be non-negative, because technically it could be 0. Okay? Now, no fractions allowed. Okay, so what I normally do is I just move this x over with the y first thing. And that way, once I do that, I can see, hey, look, it's already positive. I don't have to screw with that. Alright, now, because the common denominator is 2, I simply multiply by 2, and I'm going to get 5x plus 2y equals 43. Okay. Now, the original problem up here, this guy right here, okay, you could have done the same thing. You could have said, well, I'm going to make it look like it's in standard form just for pickles and grins. And so I'm going to multiply this feller by negative 5, and I'm going to get 2x minus 5y equal negative 5. Notice how that 2x minus 5y notice how these look similar. What? But different. That is how you know that they are perpendicular lines. Notice how these dudes switched, and oh, look at that, the sign flipped. What do you know about that? Okay, so it's kind of nice, kind of easy to do it that way, but again, I prefer to use slope-intercept form, y equals mx plus b, but just be comfortable when you see it written in standard form, because once in a while it does end up that way. Okay. Now, going back to this standard form, kind of riffing on that just for a moment. How do you graph in standard form? I'm going to use a gross number. Alright, Q. Well, you could put it over to y equals mx plus b format, but I got better things to do than do a lot of algebra. So this is what I do. I want to know what happens when y equals 0. Well, listen, friend, if your y equals 0, you're on the x-axis somewhere, are you not? I believe you are. So if you plug y equal to 0, now you're going to get x equals 8. 1, 2, 3, 4, 5, 6, 7, 8. The point 8, 0 is on the graph, and this right there is an x-intercept. Nice. Well, dude, what happens when x equals 0? Well, if x equals 0, we're on the y-axis. So that would be x is 0, so it would be 5y is 24, so y would equal 4.8. Nice. 1, 2, 3, 4, 0.8. Voila, friends, and I'd give you this guy right here is the y-intercept. And this line is 3x plus 5y equal 24. And it's just an easier way to graph it. Your book calls it the intercept method. I actually used to call it the palm method, because I used my palm to cover up the x's, and then I would cover up the y's and just do it that way. I used to teach kids doing it that way, but I don't know. I don't know if it really helped or not. Just sometimes it was nice, sometimes it wasn't. Whatever. A couple other things to review. The distance formula. Most of you memorized it as a formula. I don't really care for that method anymore. I used to teach it that way, honestly, but I don't anymore. Because the distance formula is just Pythagorean theorem. And any idiot can do Pythagorean theorem. Am I right? This is distance. Oh my gosh, it's like d squared is equal to a squared. Well, now how far is it between here and here? Well, I believe it's x2 minus x1, Mr. Groom. You're not wrong. And how far is it from here? It's y2 minus y1, Mr. Groom. Oh, you're not wrong. Hey, that's Pythagorean's theorem, indeed. And if I simply do this, this is the distance formula that we all know and love. Or loathe, I don't care. Nobody cares if you like it or don't. But just deal with it. Okay? Okay. Now, how do I find the midpoint between these fellers here? Well, it would be the average of their x's and the average of their y's. That's where the midpoint would be. Okay, and the midpoint would be d over 2 apart from the first point or the second point because it's halfway. Alright, and the last thing I wanted to talk about was, if you recall, completing the square. I know you guys did it because I remember helping some of you last year. And if you want, I will mention your names. So, I don't use it to solve. I don't think you should ever use completing the square to solve an equation. Okay? I think that's ludicrous. But occasionally it's nice in calculus to be able to use it to rewrite a formula into a way that it would fit into some forms that we've seen, so we could simplify our lives a little bit. At first you won't think it's simplifying, but I promise you it is. Anyway, if you'll recall, some people teach it a little bit differently, but Mr. Groom just says, hey, move this c, remember it's ax squared plus bx plus c. Move this c feller, just scooch him out of the way, get yourself a little room to work here. Nice. And then we are going to take half of this b term. So that's 5 over 2. Yes? 2.5 if you like, but I just like 5 halves. But you do what you want to do. Squared. It's always this. That is because this guy right here now always factors x plus 5 halves squared. This part here will always factor like that if this guy is half of this guy squared. Nice. Holy buckets though, this is 2.5. 2.5 squared is 6 1/4. You just added 6 1/4. You can't do that and not undo it. So by adding it here and subtracting it here, I've added a whopping big fatty 0. So this guy right here is 100% the same as the original function. I'm going to prove that to you in Desmos.com and see what you think about that. Oh my gosh, I only see one function. That is because, oh fart. That's because it's the same one. Yeah! Check it out too, dog. Negative 2.5, negative 7 1/4. What? Remember, we talked the other day a little bit about transformations. So what we're saying here is we have the function x squared, and we are doing this to it. Right? So we're saying that the vertex is located at BC. This is supposed to be negative in here, so when it's negative, that means when it's positive, that means it's negative. So the vertex is located here and here. In other words, we've taken this fella right here, we've shifted it to the left 2.5, down 7 1/4. Okay. By the way, how would you describe this graph? Yes, it's a vertex. But this point is what we'd call a minimum. Yes? It's at the bottom of the graph. Well, that's a pretty easy one. A little grosser one might look something like this. Oh, that's so gross. Why are you doing this to us? Do you hate us? Yes. Yes, I do. Now, here's the game. We are going to, once again, scooch C out of the way. That's what I call it. Scooch it. Just move it over there. Get it out of your way. Notice it's on the same side of the equal sign. We're just giving ourselves a little room to work here. And you're thinking, I paid attention, I want to take half of this guy. Not so fast there, Haas. Not so fast. This guy out in front of the x squared needs to be a 1. What? You didn't do that last time. It was already a 1 last time. Ah, crud. So, what we're going to do is we're going to factor that out. And we're going to factor it out of both of these pieces. But Mr. Groom, 3 doesn't go into 7. Sure it does. It goes in 7/3 times. It's cool. Now, what is half of 7/3? The last time I checked, it was 7/6. And all you have to do, any fraction, hey, here's 1/13. What's half of that? It's 1/26. What did you do? You just times the bottom by 2. That's correct. Because if I want to divide it by 2, that's the same as taking half of it, yes? And that's 1/13 times, remember this is 2 over 1, 1 over 2. Nice. So keep that in mind when you're doing these guys. It's not that hard. We're going to do a couple for practice. We'll do more of them later in the term. Now note, I'm going to go ahead and distribute this one out because I think it's a little easier maybe sometimes to see if I do that. It's going to be plus, obviously, 49/36. And a person would want to say, hey, you added 49/36. Not so fast. Not so fast. Everything in the parentheses is multiplied by 3. Am I right? I believe I'm right. If you take 3 over 1 times 49/36, cancel, cancel, 12, I've really added 49/12. So over here somewhere I better minus 49/12. Now, I've been doing this a long time. I usually skip this step right here. I usually skip it because I've been doing it long enough. But if you can't do it without skipping it, then you shouldn't skip it. You should go ahead and show that. Now, I go to the previous up here. I bring the 3 down. I bring this down. I bring an X down because that's that right there. I bring what's in the parentheses here down. So minus 7/6 squared. And then this is 60/12. Minus 49 is 11/12. So that means my vertex is going to be at 7/6 and 11/12. Okay? Now, here's the good news. This parabola opens up. We know that, right? Because it's positive. So it opens up. Which means this dude here is that's right, a minimum. Okay? All right, one more, I think. And then I think we'll call it a night. Well, Mr. Groom, there's no C. That makes it even easier, baby. It makes it even easier. So, what I'm going to do is I'm going to factor that -2 out. Right? So what's half of -5/2? It's -5/4 squared. Now, 5/4 squared is 25/16. Last time I checked, yes. But it gets multiplied by this -2 over 1. So that was going to be now wait, these cancel. So it's going to be -25/8. So because it's positive in here, because that's positive when you square it, and it's positive. So then it's -2 times that's going to be -25/8. So I better add 25/8 out here. Again, this should not be brand spanking new to you. This is just a review. So bring the X down. I do it this way. Other people don't. This is the way that makes me the happiest. And so my vertex once again is at 5/4, 25/8. And because this is negative, she opens down. Therefore, this vertex is going to be a maximum. Let's go look at the graph of that dog just for fun. Oh, fiddle faddle. I totally spaced off what the equation was. Oops, nope. -2x squared plus 5x. Dude. And -2x minus 5/4. Bam! Oh, it is good to be good. Nice. Anyway, that's what you're going to be working on today on your assignment. That kind of tidied up a little bit of section 1, but it's mostly section 2 stuff. So section 1 and section 2 you can totally do now. Keep yourselves occupied and yeah, have fun.